Hello folks, welcome to what is probably the first video in the Math 9b series. The first unit we're going to talk about is powers and exponents and some different rules that have to do with that. So in today's video, we're just going to introduce the idea of what is a power, what are some of the rules that have to do with powers, and just some of the terminology and whatnot. Okay, so here we go. When we're thinking of powers, one of the things that we can do is we can start thinking about them in terms of their shape, the geometry that is associated with them. So what I mean by that is, if you think about something that is to the power of 2, right, what do we usually call that? Well, we call that a square, right? We say like 2 to the power 2 is 2 squared, and that's equal to 4, or 3 to the power 2 is 3 squared, and that is equal to 9. And when we did Math 9a, we talked about perfect squares, and we kind of already made this association that the reason we call it a square is because it's actually defining that shape, the shape of a square. If I take a square with side length 2, well, its area is going to be 4, and the square with side length 3, its area is going to be 9. So we call these 4 and 9 and 16 and 1 square numbers. But in this course, we're going to take powers one step further. We're not going to limit ourselves to just squares. We're going to look at powers of many different sizes. So if I take, for example, a 2 and I put it to the power 3, well, that means we're doing 2 times 2 times 2, and we call this a cube. And again, the reason we call it a cube, much like the reason we call these numbers over here squares, is because this is actually a way of describing the volume of a cube, right? The formula for volume is length times width times height, right? Or in this case, if I had a cube of side lengths 2, 2 times 2 times 2, which is 8. So we call 8 a cube number, just in the same way that we would call 4 and 9 square numbers. All right, so that's 2s and 3s. Now, that is not the only type of power, though. So we should start to understand that there are many different types, not types of powers, but many different combinations of numbers that we can put together to make powers. And when we do that, we have a way of naming them. So this is 5 to the 3, or 5 exponent 3, or 5 to the power 3. Lots of different ways that we could refer to it. But basically what this means is this whole thing right here, the 5 and the 3, we call it a power. Okay, so if you ever hear someone refer to a power, they're talking about a big number and a small number in the superscript up here. Okay, a power is made up of those two things. It's made up of the big number, which we call the base, and it's made up of an exponent, which we call, it's made up of that smaller number, which we call an exponent, right? So we would say that this exponent is something called a superscript, and what I mean by superscript is it's above the base. Okay? What this is telling us to do is it's telling us to take whatever the base is and to multiply it by itself however many times the exponent is telling us to do that by. So this would take the number 5 and it would multiply it by itself 1, 2, 3 times. That's what it means to do 5 to the power 3. Now, be careful, because a lot of students will see a 5 and a 3, and they'll think the answer is supposed to be 15. And that's not what powers tell us to do. They don't tell us to add it to itself 3 times, because that's what 5 times 3 tells us to do. It's 5 plus 5 plus 5. 5 to the power 3 tells us to multiply by itself 3 times. So 5 times 5 is 125. Sorry, 5 times 5 is 25, and then times another 5 is 125. So with that in mind, how would we take an expression like this, where we have 1, 2, 3, 4, 5, 6 threes, and write those out as a power with, well, we would do it, we first decide on the base. So we look at the number that is being repeated. So in this case, that's a 3. So this 3 is the number that's being repeated. So that is the base of our power. And then we count how many times it's being repeated to determine the exponent. So 1, 2, 3, 4, 5, 6 of them. So 3 exponent 6. Now, this one seems a little odd. It's just a 7 by itself, so there is no multiplication happening. But we can still use powers to help us describe this answer. So again, we're looking at the number that's being repeated. So it may not be repeated, but there's still a number here. So the base is still 7. And again, we're counting how many times is this 7 being multiplied by itself. And again, you might be saying, well, it's not. Like, there is no multiplication happening here. Okay, fair, but how many 7s are there? Well, there is one of them. So we can still use a power to help us describe this 7 as 7 to the power of 1. And it may not seem useful to do something like that yet, but what's going to happen is as you move along in your math career, you're going to be asked to do things with x's and factors and lots of other things that are going to be put to powers. So making this understanding that this is 7 to the power of 1 now is going to help us further on down the road. So how do we then go backwards, do the opposite? Well, we do exactly that. We take the base, which is the big number, and we say, okay, the base here is 3. And then we look at the exponent to tell us how many 3's it's going to be. So 3 times 3 times 3 times 3 times 3. So 1, 2, 3, 4, 5 of them. So if you're ever looking to answer one of these questions and you don't have a calculator in front of you, because a lot of calculators have that exponent button, then we have to understand that this is 3 times 3 times 3 times 3 times 3, 5 times. Now, in order to then write this out in what's called standard form, basically what that's saying is, what's the answer, right? So after I do this 5 multiplications, what do I get as my answer? And there's a lot of different ways that I could do this multiplication. Personally, I like to pair them off because I know that 3 times 3 is 9. And then this 3 times 3 is also 9. And I can do 9 times 9. Most of us know that 9 times 9 is 81. So this thing just becomes 81 times 3. Well, 8 times 3 is 24. So 80 times 3 is 240. And then 1 times 3 is simply just 3. So this thing turns into 243. All right, great. Again, same thing with this one, 7 to the power of 4. What does that mean? It tells me to take a 7 and to multiply it by itself 1, 2, 3, 4, 4 times. And again, to write this out in standard form, we're essentially just looking for the answer. So again, I can do 7 times 7. So I know that this thing becomes 49 times 49. And maybe you can't do 49 times 49 in your head, but you can probably do 50 times 50 because 5 times 5 is 25, right? So 50 times 50 is 2,500, right? And this is just taking away one of those 50s. So that's 2,450. And then this is taking away a 49 from that. So it's 2,401. And again, if you had a calculator handy, you could type that in and do that out yourself. Okay. So something to be aware of when we're talking about powers is this idea of when is my base negative and when is my base not negative. So here's an example of a power, right? We have -3 to the power of 4. Notice the position of the brackets. Okay, notice that the -3 is inside a set of brackets, whereas with this question B over here, the -3 is not inside brackets. It's -3 with no brackets, and that's being put to the power of 4. One of the ways to remember what this means is to think back to order of operations. In order of operations, right, we know that it's B, E, D, M, A, S, or BEDMAS, right? And what BEDMAS stands for is it tells us to do the brackets first, right? So do brackets and then do exponents, right? And then we're going to do division and multiplication as one group, left to right, and then addition, subtraction as one group from left to right. So I want you to know that this negative here can be thought of as a multiplication. So it's actually -1 times 3. And if we think about it like that, using our order of operations is going to help us decide what comes first. So in this case, we're going to do the -1 times 3 first, and then we're going to take that answer and put it to the power of 4. So in this case, the base of my power is -3, and the exponent is 4. So what does that mean? It means -3, sorry, times -3 times -3 times -3. Or again, pairing these off, we get +9 because -3 times -3 is a positive. And another +9 gives us 81. Now, over here, what the question says to do, again, order of operations says we want to do the exponent first because there are no brackets here. So we're going to do the 3 to the 4 first, and we get 3 times 3 times 3 times 3. Then we're going to multiply that by -1. So again, 3 times 3 times 3 times 3 is 81, but this negative didn't get repeated. right? So this negative in this case is still there, and we get negative 81. And then on the third one, both is happening. So we're going to take, oh, never mind. Again, we have to consider the position of the brackets. Notice where the 4 is. The 4 is not outside my bracket. The 4 is inside that bracket. So again, we're going to get the negative of, and then we have 3 to the power 4. 3 times 3 times 3 times 3. So again, 3 to the power 4 is 81, and we get the negative of a negative. So again, when I do a negative times a negative, I get a positive, so this thing turns into positive 81. So now let's go back to what the question was asking, because it said to identify the base of each power. And I want you to look at the repetition. In which example did the negative get repeated? Well, that only happened in question A. So in that case, the base of my power, because the negative is also being repeated, is negative 3. But in questions B and in question C, the negative does not get repeated. So in these questions, the base is positive 3. Okay? So depending on where my brackets are and where my negative is, will determine, I don't know why I put a 4 there, will determine whether the base is negative or the base is positive. All right, that's it for today's video, and I'll see you all in the next one.